Hello everyone, Mr. Fawcett here, and we are about to start our first actual geometry lesson. Last lesson we just reviewed some different types of one variable equations that it's good to know how to solve before you enter geometry. Today we're going to start with our fundamental definitions, which are kind of the building blocks of the rest of this geometry course. So you guys can work through the do now. That's just for different equations for you to solve based on the ones we did in our last video. But I am going to jump down to our definitions. So the first definition, a point is an exact location represented by a dot. Points have no size, only a position. So a point is actually something that has 0 dimensions. So it's not a thing you can pick up. It's not a thing that has any size. It just represents a specific position in space. The way we write points is we just write the capital letter that corresponds with a point. So if we have point A, we just label that as point A. Over here, we have a line with several points on it. If you wanted to label these points, you would just label them as D, E, and F. Now, this M right here is not a point. It is just the name of the line. So D, E, and F are points on the line. M is the name of that line. Which comes to our next definition. A line is a continuous series of points that extends in 2 opposite directions without end. So a line is something that is one-dimensional. It has no width and it has no measurable length. So it just extends infinitely in both directions. The way you write the notation for a line, there are a couple different ways. If we come over here, and I'm just going to go for our example here, you can pick 2 points on the line. So I'm going to pick D and D. And you put them next to each other with a little bar with arrows on top. Okay. You could pick 2 other points. You could choose E and F, or we could choose D and F. Note that you could also switch these around. So you could also have ED, FE, and FD. Now, if you have a letter that's not on the line, so this little M right here, right, that's not a point. That is just the name of the line. Instead of choosing 2 points, it would also be A-OK to just write line M. So you could write what I have boxed in green, or you could go with any of the pink notations as well. Okay. One thing to make sure you do is make sure you put these little arrows on the end of your bar on top of the whatever 2 letters you choose. Now, what would be incorrect would be if I did 3 letters. So if I did line D, E, F, that would be an incorrect notation. You strictly want to use 2 letters if you're using the notation with a bar with arrows on top. Okay? All right, let's go down to our next word. Collinear points. These are points that lie on the same line. So you could think of it, if you can draw a line between that connects all 3 points, those points are going to be collinear. So an example over here, here's 3 points, A, B, and C. And these are collinear because I can draw one line that connects all of them. And of course, a line, as we talked about up above, a line is made up of an infinite amount of points. So you could technically come up with an infinite amount of points that are collinear because all lines have an infinite number of points. Non-collinear points are points that cannot be connected by a single line. So you can look at the example right here. There's no way for me to connect D, E, and F with one line. I can connect two of these points. Let's do a little better job. I can connect two of these points with one line. Right, I can connect D and D, or F and E, or F and D. But there's no way for me to connect all of those single points with one line. So again, you could draw your own points. I'll just call these X, Y, and Z. These 3 points would be non-collinear. One interesting thing to think about is, could you draw 2 points that are non-collinear? So could I just have, I'll do this right here. Could I have 2 points, let's call them P and Q, that are not collinear, right? Could I move Q around so that you couldn't connect it to point P with a single line? And the answer is no. Any 2 points are always going to be collinear because you can draw a line through any 2 points. But as soon as you have 3 points, that's when you can start to have non-collinear points. Okay, let's move on to the next word. A segment is a part of a line that consists of 2 endpoints and all the points between them. So if we come over here and look at our example, a segment is still made up of an infinite amount of points, but it has strict endpoints. So it does not extend forever. There are 2 clear places where the segment ends. The way you can name it, you use the endpoints. So AB or BA, it doesn't matter the order. What you need to pay attention to though is notice that there's no arrows on the bars on top of the letters. Okay, if there were arrows, we'd be talking about line AB or line BA. If you leave the arrows off, it becomes a segment. So if we come over here to segment CD, I could name this segment CD or segment DC. Let's say I added another point on this line. Let's say I added point A. And let's say I still wanted to name the entire segment. So the whole thing from C to D. Well, again, I'm not going to use 3 letters. This would be incorrect. No good. I only need the endpoints. Also, this would be incorrect. AD. Because that does not name the entire segment. With a line, you can choose any 2 points on the line. But with the segment, you must use the endpoints, because that's going to tell you what segment you're talking about. If I talk about AD, that's a segment, but it's not the entire segment. Okay, so segments, you must use the endpoints. Next vocab word, array is a part of a line that has a clear endpoint and extends infinitely in the opposite direction. So we come over here and look at our example. There is one point where the ray does not pass, and there's the other side of the ray that continues to keep on going. Okay, so there's one starting point or one end point, and then the ray continues to go in the other direction. So the way you name a ray is you always have to start with the endpoint. Okay, so our endpoint here is A. That's where the ray stops. You must start your notation for naming a ray with the endpoint. That also means if we come over here to ray EF, even when you say it, so even when I read this, even though the F comes first, E is my endpoint. So I'm going to start by saying ray E rather than ray F. So it's got to be ray EF. That means my ray, my endpoint is E, and the other point on the ray can be F. Okay, I could name this ray EF, or I could name it as ray EF. They're both read the same way. Sorry, that would not be correct. Still got to have the E under the non-arrow part of that ray. So you would read both of these as ray EF. They mean the same thing because notice that the E is underneath the end point of that arrow in both scenarios. Okay, now we're going to move on to something that is two-dimensional. A plane. So a plane is a flat surface that extends in all directions with no end. So many times people like to think of a plane as a sheet of paper or a wall. The thing you just have to realize is that just like a line, so a line keeps going in all directions, a plane also extends in all directions. So if you're going to think of a plane as a piece of paper, well, you'd have to think of a piece of paper that is infinite. Okay, it doesn't have a width, it doesn't have a depth, right? But it has an infinite length and an infinite width. Naming a plane, you can use just a single capital letter as long as that letter is not a point on the plane. So notice over here, this can be called plane P. That's because this P is not a point. Okay, so sometimes they'll give you one letter to name the plane by, but that will never be one of the points on the plane. If you are going to name the plane using points, you must use 3 or more non-collinear points, and we're just going to use 3. So you can choose any 3 points on the plane as long as you can't draw a line that connects all of them, right? Because they need to be non-collinear. And in this case, these would be all of our options. It does not matter the order. They just need to be 3 non-collinear points. Let me draw you a little reason for why the points must be non-collinear. So let's say I have 3 points that are collinear. Say A, B, and C. And let me draw a plane between them using purple. Okay, so there's one plane that you could draw. However, think about if you spun this plane. So, I don't know, just think about it as like a sheet of paper that's being held in the center and you just spun it. Well, then you may get a plane that looks like this. Right? It's just a little more flat as you start to spin that plane around. I could keep going. I keep spinning the plane, and I may get something that looks like this. Again, as you keep spinning that plane around, it would not be the same plane. So if you have 3 points that are collinear, you can have an infinite number of planes that they could all lie on. But as soon as you move one of those points, as soon as you move them so one of them is not on a line that connects the other two, there's only one possible plane that goes through all 3 of those points. Okay, so hopefully that visual explained why you need to use 3 non-collinear points to name your plane rather than using 3 collinear points. So let's come over here and let's practice naming a plane. We are going to name plane R. So we can either say plane R, or we can pick 3 non-collinear points. Just to be clear, this is where our R is. So we could name it using G, B, D. That's one way. We could say G, F, D. We could say A, B, F. And now think of 3 letters that wouldn't work. So think of a way that would be incorrect. Well, if we said B, D, A, that would be incorrect because those 3 points are on the same line. They are collinear, which means we cannot use them to name a plane. And here's a perfect example. A, D, and B are on plane R, but they're also on plane P. So if we just say plane ABD, how do we know which plane we're talking about? Right? It's kind of like what's going on over here. If I say plane ABC, am I talking about the purple, the green, or the red plane? Another way that would be incorrect would be if I said plane C, B, F. Okay, and this one's incorrect because those 3 points aren't on the plane we're talking about, right? They would all have to be on plane R for that to work. Okay, so those are our definitions for the day. We are now going to look at some problems and some questions that ask us to kind of parse through these definitions and make sure we know exactly what they're saying. You know what? We are going to pause the video here actually, and we will come back and do these practice problems in part 2. So hope to see you then. Until then, as always, enjoy the rest of your day. This is Mr. Fawcett with another geometry lesson.